So first things first, let's understand the difference between value types and reference types in C# and .NET. In the previous modules, we have already used a number of types. We have used some of the built-in primitive types, such as int, decimal, and datetime. And in the previous module, we have created our first custom type, the employee class. In .NET, and thus also in C#, there are two categories of types, value types and reference types. These two categories basically behave differently. All types fall into one of these categories. We have, without really thinking about it at the time, worked with value types from very early in this course. All primitive types like int, float, double, and char are value types. Based on the selected type, the compiler will allocate memory for this on the stack. The type itself determines how much memory is needed to contain a value of that type. The actual value is placed in this memory location, so the value is directly stored in the memory location, hence the name value type. Let's see this inside of a diagram. Here we create a few integer values, a equals 1 and b equals 5. What's essentially happening here is that these variables are created on the stack and they immediately contain their value. If we could look in the memory of our C# application, think of it like a box with a label A, and when you look in that box, it'll contain the value 1. Reference types are different. They are allocated on the heap. The heap is the mass memory of the machine. In this case, the value on the stack will not contain the actual value. It will contain a pointer to the memory address on the heap where the object is allocated. Indeed, what gets allocated on the heap is the object, so classes follow this pattern. Classes are indeed reference types, the most important ones, that is. Here's our diagram again. The actual object will be created on the heap. O, the variable, doesn't contain the actual object. Rather, it contains a reference to the actual object on the heap. If you have been working with C++, this will look very similar to a pointer, and that's exactly what it is. However, C# is a managed language, meaning that we don't need to clean up our objects manually to free up memory space. Let me prove to you that classes are reference types by means of a small code example, and we'll use our employee again. I'm first creating a new instance, and then I'm setting the name. Employee1 is a variable pointing to an actual object created on the heap. I then create a second variable, employee2, and I set it equal to employee1. At this point, we have two variables pointing to the same object, and that I can prove. If I now, through the employee2 variable, change the first name of our object, and I set it to George, and then I use employee1.firstName to get the value of our object's first name through the employee1 variable, we'll get back George. Why is that? Think about this for a minute. Maybe pause the video. In the next slide, I will show you a diagram that explains this in a bit more detail. What we have done is we have one object on the heap and we have two variables pointing to that same object. When I thus change the field's value, it is changed on the actual object, which is allocated on the heap. Employee1 and employee2 are just variables that point to the address of our actual object, and it was the latter that was changed.